Okay, so hi everyone, Senan this side, and in this video we are going to solve this lowest common ancestor of a binary search. So you would be given a BST, find the lowest common ancestor given two nodes in the BST. So you would be given the tree root and two nodes of this tree P and Q, and you have to find a common answer or basically the least common ancestor because the root would always be an ancestor to P and Q, right? So we need to find the ancestor that is the closest to P and Q. Now let's look at this case. So if P is 2 and Q is 8, so this node and this node, and so the root node would itself be the lowest common ancestor because you cannot find an 8 beyond this. So 8 is on the right and 2 is on the left. So that means this is the node itself, which would be the least common ancestor. In this case, you see P is 2 and Q is 4. So one more thing, that we allow a node to be a descendant of itself, or in other words, a node can be an ancestor of it, right? So the definition of LCA is basically defined between the two nodes P and Q as the lowest node in T that has both P and Q as descendants, where we allow a node to be a descendant of. Okay, so in this case we have P as 2 and Q as 4. That means we are talking about these two nodes, and we know the lowest common ancestor is what? 2 itself, because we can consider the same element as an ancestor to itself or descendant of itself. So we have to return the answer as 2. Now if you observe, at given any node, if the value of P and Q is both less than this node, that means there is a LCA on the left hand side. So P is 2, Q is 4, and that is less than 6. So we are sure about this, that the LCA would be on the left hand side of this. On the other hand, P and Q has a value greater than this root node, so we are sure that the element or the LCA that we are trying to find is on the right of the subtree. And why do we know this? Because we know this is a binary search tree. This is the only reason we are able to find this out. Now let's look at the code of how are we actually going to implement this. So first of all, I take a temporary node, a pointer to this tree node, and point this to root. Now since P and Q, so given P is not equal to Q, P and Q will exist in the BST, so that means this root is not null in any case, and obviously P and Q cannot be null, so this tree has at least two nodes, which you can see in this case. Now I find out the minimum value between the P and Q and the maximum value between them, right? And now while true, given this temp, I check if this temp, if mini is less than temp val and maxi is greater than temp val, that means the node that we are trying to find P and Q are on the opposite subtrees, right? So that means we are at the least common ancestor. So what we do is we return this. This was the case where the root node is not having the values of P and Q. So root, the temp node that we are talking about, is neither the P node nor the Q node. In that case, you return the temp as it. Otherwise, if either of them is same, so if P is temp.val is 2 or 4, like in this case 2 or 4, we return the temp value because the node which is at the topmost level would and has the value same as P or Q would be the least common ancestor, right? Because we can consider itself. Okay, so in that case we also return temp. Now if we reached this else if statement, right, that means when would this condition be false? This would be false only when if either mini is greater than temp val or maxi is less than temp val, right? Because every value is unique, so either one of this will be true, right? So if that is the case, if temp val is less than mini, so that means that the value that I'm at and the nodes that I'm trying to find is on the right hand side of this tree. So I update this temp to temp dot right. Otherwise, if we reach this else statement, that means temp dot val is greater than maxi, so that means our answer should be on the left subtree. So that is why I return temp is equal to temp dot left. Basically this is arrow, but because these are the pointers, but if it would have been an object, we use the dot operator, right? So I just call this as dot. I know that is not the dot. So otherwise, so since we are not going to get out of this while true loop, I just for the sake of writing the return, I say return null. But at some point of time we would reach this temp value because we are trying to go towards the nodes which have the value P and Q, and if it is either equal to them, we return that value, and if it is within the range, again then we return the value, the temp node. So this is pretty much running. You can see accepted, and yep, that was the whole video all about. The time complexity would be what? It's basically the height. The worst case you would reach the lowest node, which won't be the case, but let's say you reach lowest node, so that could be the maximum height of the tree. So that is the time complexity, and the space complexity would be constant because we are not storing something else, right? Now if it would have been that p and q could be null, they don't exist, or root may not exist, you may need to add some more if else statement, but given the constraints, this is more than enough. Yep, that was the video. Thanks for watching, and I'll see you in the next video.